So we're going to do some examples today, and you're going to have a chance to try some problems on your own at the end with solving rational equations. So we're going to start with a problem like number 1, which is sort of the middle school version of what we're learning about now. So back in middle school, you probably learned how to solve proportions, and a strategy that you likely learned was cross-multiplying. So before we go any further with this video, I want you to pause it for a moment and take a look at number 1 and think about what are all the ways that you could solve that proportion and figure out the value of x. So take a moment, like I said, pause it, see if you can come up with multiple ways to solve that proportion. All right, so now that you've had a chance to try that one on your own, like I mentioned before, one strategy is to cross-multiply. So when you're cross-multiplying, you're multiplying the numerator of one fraction times the denominator of the other. So for this problem, multiplying x times 3 and also multiplying 2 times 9. And so when you do that, well, x times 3 you could write as 3x is equal to 2 times 9, or 18. And then to solve that equation, divide both sides by 3, and you would get that x equals 6. Right? So that's one strategy that you could use on this problem. Maybe you thought about, well, from 3 to 9, you could multiply this by 3. So maybe you thought of it as like, okay, well, you had x over 9 equals 2 over 3, and to get from one fraction to the other, you could think about it maybe like scaling up. So scaling this up by a factor of 3, which means you would also scale up the numerator by 3. And so when you do that, well, 2 times 3, you would end up getting 6, right? So you would get the same answer that you did from cross-multiplying. Or another option here is with this original problem, x over 9 equals 2 over 3. Kind of similar to the scaling up idea, but instead of thinking of it as getting from one fraction to the other, rewriting this denominator to be the same as that denominator. So multiplying this denominator by 3, and then you would also have to multiply the numerator by 3, right? And that 3 over 3, this is that convenient form of 1 that we keep talking about in class. I'm going to draw a big 1 around that. And so then, if you multiply, well, 2 times 3 is 6, 3 times 3 is 9. So x over 9 is equal to 6 over 9. So if these two fractions are equal and the denominators are the same, then wouldn't that mean that the numerators would also have to be equal? Like x would have to equal 6 in that equation. So 3 different strategies here. So cross-multiplying, or this idea of like scaling up, or getting a common denominator. These are ways of solving proportions. So on the next couple problems, we're going to focus on cross-multiplying, and then this idea of, well, if we can get the common denominator in both fraction, then we can, it's almost like we're just kind of eliminating those denominators, right? It's not like we're like canceling them out. It's a little different than canceling. So I'm going to call that eliminating denominators, and that's what I've got labeled down here. So we're going to use that strategy several times on these problems. So on number 2, I want you to pick a strategy, so one of these strategies that we just tried, and pause the video and give number 2 a try. All right, so I'm going to do it by cross-multiplying, so similar to what we did first over here, and then also by getting a common denominator. So if you cross-multiplied, doing 5 times x minus 5, and you could write that as 5 times x minus 5, and then also multiplying 4 times 15. So distribute the 5 here, right? So it'd be 5x minus 25 is equal to 60. And then solve that equation, right? So now it's just a 2-step equation. Add 25 on both sides, and you would get 5x equals 85. And then divide both sides by 5, and you would get 17. So that's how you would solve this, this proportion using cross-multiplying. The other option is maybe you got both fractions here to have the same denominator. So this denominator is 15. It wouldn't be too hard to get this denominator to also be 15. So if we multiply that by 3 over 3, this other convenient form of 1. So then this would be x minus 5 over 15 is equal to, well, 4 times 3 is 12 over 15. So we have two equal fractions. They have the equal denominators. So just logically then, the numerators also have to be equal. So this x minus 5 in this numerator has to be equal to 12, right? And so then this equation might even be easier to solve than the equation on the last one, right? So here it's only a one-step equation, add 5 on both sides, and you would once again get that x equals 17. So take a moment, kind of decide for yourself on this problem, did you prefer cross multiplying, or did you prefer getting a common denominator and sort of like eliminating the denominators and just solving for the numerator? All right, and we're going to try number 3 next. So whichever strategy you're considering, notice that on the left side of the equal sign, we've got a fraction being added to a fraction. So if we think about cross multiplying right now, well, we're going to have to combine these two fractions before we can cross multiply anything. And to be able to add the 1/3 to the x plus 5, those have to have a common denominator. So we can get both of these denominators to be 15 pretty easily, right? So multiply the x over 5 by 3 over 3, right? So that's our form of 1. And multiply the 1/3 by 5 over 5. So then, well, 5 times 1 is 5 over 5 times 3 is 15 plus x times 3, or 3x, over 15, which is equal to 11 over 15. And then you can add these two fractions together. So we can't actually combine the 5 and the 3x, but you could write that as 5 plus 3x in the numerator. And then this common denominator stays the same. So equals 11 over 15. And then you get to choose now which strategy you want to try. So I'm going to let you guys finish this one. So either cross multiply, in which case you would have to distribute this 15 to the 5 and the 3x and multiply 15 times 11. Or if you would rather, since the denominators of these two fractions are the same, we can work with just the numerators and you could solve this equation, 5 plus 3x equals 11. So pause the video and finish solving this one using whichever strategy you prefer. All right, we're going to look at number 4 next. And if you notice on each of these problems after here, so numbers 4, 5, and number 6 on the back, we are going to solve each of these rational equations using both of these strategies. And so as we do each problem, I want you to think about, which strategy seems easier to you on that problem. And then by the end, if you're looking ahead at the back, on the last 4, you are going to be doing these problems on your own, and you can choose which method you want to use. So I want to give you multiple strategies, and these strategies you may prefer one over the other. You may find one easier. You also may find both of them useful, but maybe one is more useful on a certain problem than another. So I think it's important, we've talked about before, about having multiple strategies and being able to use them flexibly. So on number 4, if we're going to cross multiply, it would probably help if we wrote that 2 as a fraction. So writing that maybe as 2 over 1. And then, so I'm going to write this down here, x over x minus 3 is equal to 2 over 1. So when you cross multiply, we're going to multiply the 2 times the x minus 3, and we're going to multiply the x times 1. So you could write that 2 times x minus 3 is equal to x times 1, or just x, right? And then solve this equation. So distribute the 2x minus 6 equals x. And then there is a variable on both sides, so at some point during this solving, you're going to need to bring these together. So either minus 2x to bring that over, or minus x. I would prefer to keep that coefficient positive, so I would probably prefer to do minus x on both sides. That is going to leave me with a 0 on this side of the equation. So we'll have an equals 0 over here. 2x minus x, or just x, and then the minus 6, and then finish solving that by adding 6 to both sides. So this is not the only way to solve this equation. It's just one option. So you get the x equals 6. And anytime you're solving any type of equation, right, you can always plug this answer back in for these x's here and make sure that each side of this equation really is equal. All right, so that's cross multiplying on that problem. We're going to solve this same equation, but using this other strategy of getting a common denominator, and then we can sort of eliminate the denominators, meaning focus on just the numerator. So I'm going to just write this original problem again, and I'll write it as 2 over 1 like we did up here. So to get a common denominator for both fractions, well, this one's got an x minus 3 and this one does not. So we could multiply this fraction by x minus 3. So 1 times x minus 3 is just x minus 3. So we'll also multiply the numerator by that. And once again, that is just a convenient form of 1. So the next step of this will 2 times x minus 3. Right, so 2 times that. You could go ahead and distribute those together if you want. And then in the denominator, 1 times x minus 3, or just x minus 3. So you have x over x minus 3 is equal to this. So the strategy we're trying to use here is, get a common denominator, and then we can almost like eliminate the denominator. Eliminate's not a very mathematical word, but I wanted to come up with something other than canceling, because it's a little different than canceling things out. But if we have two fractions that are equal to each other, and the denominators are equal, then logically the numerators have to be equal as well. So this x has to be equal to this 2 times x minus 3. And then if you notice, this equation right here looks familiar because we actually solved it over here. So in these two strategies, you start a little differently, but you end up actually with the same exact equation. So I'm gonna let you guys do this one, right? Because we just solved it over here, right? So your steps will be the same. So maybe pause the video, finish solving that one. If you want to challenge yourself, maybe come up with a different way, like do your steps a little differently than how we solved it over here. All right, let's look at number 5. And again, we're going to solve this rational equation using 2 different strategies. So we'll start with cross multiplying. So we will need to multiply 6 times the 6x plus 7. I'll go ahead and write that. 6 times 6x plus 7 is equal to 10 times 2x plus 9. So to solve this, we've got to distribute again. So that would be 36x plus 42 is equal to 20x plus 90. And then solve this equation. So you've got a lot of options here with what you want to do for your next step. So at some point you will need to bring those x's together. But really, I mean, you can move anything in this equation. So you can move the 36 over, move the 20. You could subtract 42. You could subtract 90. So your choice. I know that it'll be easier for me if I can keep the coefficient on the x's positive. So I'm going to start by subtracting the 20. So 36x minus 20x would be 16x plus 42 equals 90. And then maybe subtract the 42 on both sides. So that would be 48. So 16x equals 48. Divide both sides by 16 and you would get x equals 3. So in this class, I am fine if you don't show all of your steps in here, right? You've been solving equations at this point for a lot of years. And so if you're becoming quicker at it and more fluent and you don't need to show every step, that is definitely okay. All right, so we got our solution. So we're gonna solve this equation using this other strategy, and again, be thinking about which strategy seems easier to you in this problem. So I'll write our original problem again. So to eliminate the denominators, we need both denominators to be the same. So take a moment and think about, well, what do you want the denominators to both be? And one option would be to multiply this fraction by the other one's denominator, and then multiply the fraction on the right by this one's denominator. Meaning we want to multiply this by 6x plus 7 over 6x plus 7, and multiply this fraction over here by the 2x plus 9 over 2x plus 9. So then we end up with both factors in both denominators, right? And I'm going to draw my big ones around this, because we're just multiplying by convenient forms of 1. So I'm going to go ahead and distribute here, right? So distribute the 10. That would be 20x plus 90 over 2x plus 9 times 6x plus 7. And then I'm going to distribute the 6 as well. So 6 times 6 is 36x. 6 times 7 is 42. And then in the denominator, 2x plus 9 times 6x plus 7. 2x plus 9 times 6x plus 7. So, just like we got to this point on the last problem, we have two fractions that are equal. Their denominators are equal, and so their numerators therefore would also have to be equal, right? So it's like we're eliminating the denominators so that we can focus on just the numerators. So this 20x plus 90 is equal to 36x plus 42. Right? The numerators have to be the same. And just like on number 4, we got to a point where we had actually already solved that equation over here by cross multiplying, right? We solved this exact equation over here. So I'm not going to do the rest of this one. If you want to finish solving that one, we should end up with the same answer, right? Because we are solving the same equation. So again, take a moment and decide for yourself which of those strategies seems easiest to you. And then we're going to do one more problem, and you'll have one more chance to decide for sure which strategy you want to use moving forward. All right, so on the back side, we're going to look at number 6. And if you notice on this side of the equal sign, we have fraction equals fraction. It's kind of similar to back on the front on number 3. We talked about like, well, we've got to add those fractions together before we can use either strategy. So we are going to have a common denominator here and here, whether we're cross multiplying or using this other strategy. So these two fractions are going to have the same denominator. So we'll start with that. It's helpful if you can factor this, and that can help you see how to get a common denominator. So find numbers that multiply to 12 and add to -7. So -3 and -4. So we could rewrite this denominator as x minus 3 times x minus 4. Oh, sorry, wrote my parentheses, x minus 3 times x minus 4. So to get a common denominator here with this fraction, so that we can add these together, this one needs to be multiplied by the x minus 4. So we're going to multiply numerator and denominator there by x minus 4, right? And that's that other convenient form of 1. So this fraction, and I'm just going to write this up here for right now because we're going to need this for both strategies. So to start with, we've got the 5 over x minus 3 times x minus 4 plus the 2 times x minus 4. I'm going to go ahead and distribute those. So 2x minus 8 over x minus 3 times x minus 4. And then that's equal to 5 over x minus 4. So now you can add these two fractions together. So adding the 5 plus the 2x minus 8, and 5 and negative 8, we can combine those, which would be negative 3. So that numerator would be 2x minus 3 over x minus 3 times x minus 4. All right, so combining these two fractions together to get that. And then we haven't changed anything here, so that still equals 5 over x minus 4. So we had to get this equation before either strategy, right? We need fraction equals fraction to be able to cross multiply. So let's start with this. Start with cross multiplying. So we're going to need to multiply the 2x minus 3 times the x minus 4 and multiply the 5 times the other denominator. So 2x minus 3, put those in parentheses, 2x minus 3 times x minus 4, and then that's equal to 5 times this, so 5 times x minus 3 times x minus 4. So we've got to multiply this stuff together. So multiplying this binomial times this binomial, and then also multiplying all of this together. When you're multiplying two binomials, a common mistake I see is to only multiply the x's and only multiply the numbers. But we've got to distribute the 2x to both terms and distribute this negative 3 to both terms. So 2x times x would be 2x squared, and 2x times negative 4 would be negative 8x. And so we've distributed now the 2x to both of those. So let's distribute the negative 3. So negative 3 times x is negative 3x. Negative 3 times negative 4 would be positive 12. And then over here, it does not matter what order you multiply things in. So if you want to distribute the 5 first, you could, or multiply the binomials first. I'm going to choose to do that, so I'm going to leave this 5 here. Multiply these together first. So again, we've got to distribute the x to both. So x squared minus 4x minus 3x and plus 12. We can combine like terms here and here, right? And then we'll also end up distributing the 5. So if we combine like terms first, that'd be negative 11x. So 2x squared minus 11x plus 12. And then combine these. So 5 times x squared minus 7x plus 12. And then maybe distribute the 5 next. So 5x squared minus 35x plus 60 is equal to, and then bring this down, 2x squared minus 11x plus 12. So our goal, remember, is to solve for x. So right now, there's a quadratic on both sides of this equal sign. So if we can collect all of our terms on one side of the equal sign and have a 0 on the other side, then we can factor and solve. So if we can bring each of these 3 terms over, that will allow us to solve for x. So we could start by doing like minus 2x squared on both sides. And that would be 3x squared. I'm going to go ahead and do all these in one step here. So I'm also going to add the 11x. Right? I could cross those out. So add the 11x. So negative 35x plus 11x would be negative 24x. And then also subtract the 12. So 60 minus 12 would be 48. So we have 0 equals that. So now that we have just one trinomial, we can factor this, and since it's equal to 0, we can solve for what would make each of the factors equal to 0. So anytime you're factoring, it's helpful to look for a GCF, look for a common factor. So 3, 24, and 48. Think of a number that will divide into each of those, which would be 3, right? So we can factor out a 3 from everything. So 3 times what would have to go here so that it's 3x squared? Have to be an x squared, right? 3 times what number would be negative 24x? So it would be negative 8x. And then 3 times what number would be 48? That would have to be 16. Okay, now that we factored out a GCF, can we factor this some more? So can we find numbers that multiply to 16 and add to negative 8? So still got 3. We're trying to multiply that trinomial into 2 binomials. So that's going to have to be x and x. And then numbers that multiply to 16, well, 4 and 4. And if they're both negative, then they also add up to negative 8. So x minus 4 and x minus 4. All right, so we have fully factored. Now we can solve for x because we can think about, well, in this equation here, we're multiplying some things to get 0. So the only way to multiply and get 0 is if one of these factors was equal to 0. So just like back when we were solving polynomials, well, we think about, well, what value of x can you subtract 4 from to get 0? And it would have to be positive 4, right? So x equals 4, and then this x, well, same thing, right? So if this were positive 4, then when you subtract 4, you'd also get 0. So 4 minus 4 is 0. No matter what else it's multiplied by, it'll equal 0. So we end up getting x equals 4 and x equals 4. Right? So we really only have one solution since those are the same number. All right, so that was a lot of work just to solve this one equation, right? So when we cross-multiplied, we ended up with these quadratics, which then meant that we had to factor to be able to solve this. So we're going to solve this same equation up here, which really we rewrote by adding those two fractions together. So we'll really focus on this equation over here. So we're going to solve this equation using this other method. And as we do that, I want you to think about if this seems any easier to you, right? Because this is a lot, and there's a lot of room for mistakes if you're doing all that work. So I'm going to rewrite this problem here. So 2x minus 3 over x minus 3 times x minus 4 is equal to 5 over x minus 4. So to eliminate denominators, you need to have the same denominator in both fractions. So both fractions right now have the x minus 4 as a factor, but this one is missing the x minus 3. So let's multiply this fraction by x minus 3 over x minus 3. Right, that's our form of 1. So if we go ahead and distribute that 5, then this numerator would be 5x minus 15 over x minus 4 times x minus 3. And then bring this down over here. So 2x minus 3 over x minus 3 times x minus 4. So we have two equal fractions with two equal denominators. So logically, the numerators also have to equal each other. So this 2x minus 3 is equal to 5x minus 15. And then we just have to solve for x here. So you may already be thinking, this equation seems much simpler to solve than this equation did over here, right? We're not going to have to do nearly that amount of work. So one option is subtract 2x on both sides. Bring the x's together. So that would be negative 3 is equal to 3x minus 15. Then add 15 on both sides. So that would be, let's see, we can write that one out. So plus 15 plus 15. And negative 3 plus 15 is 12. Okay, so 12 equals 3x. And then either divide both sides by 3 or think about, what number times 3 is equal to 12, which would be 4. Right? So x equals 4. All right, so we ended up with the same answer, as we should, since we're solving the same equation. Take a look at the amount of work required for each of these methods. Personally, I'm looking at this, and I'm thinking that that looked much simpler than this, right? We didn't have to solve a quadratic. We didn't have to factor down here. So, oftentimes, this strategy is going to be simpler. Looking back at the ones from the front side, it didn't really make a huge difference which strategy we used. We ended up solving the same equation on number 4 for both strategies and on number 5 as well, right? So these two didn't really matter which strategy we used. However, on number 6, this strategy was definitely easier. So on the next few problems, you are going to have a chance to try these. And you can use either strategy. So maybe you start by cross multiplying and then decide to do the other strategy, or vice versa. Just know that when you're cross multiplying, you may end up having to solve a quadratic, depending on if you're multiplying an x times an x. One tip before I let you try these, if you're getting common denominators, remember it's always helpful to factor first. So like looking back here, it helped to factor that denominator so that we knew what factor was missing here to get the common denominator. Same thing is helpful on these other problems. So like in number 7, this denominator, if you can factor that, it may help you to get the two denominators to be the same. So from this, you could factor out a GCF, which would be 2, right? So you could rewrite this as 2 times, that would be x minus 5, right? So you see how that helps you now to get a common denominator. So instead of having to multiply both fractions by the other one's denominator, you really only have to multiply this fraction by 2 over 2. So I'm going to stop the video and let you try these last 4 problems. And before you leave class today, you are going to turn this in. If you need more room, like if you run out of space on some of these, feel free to use some extra paper and you can turn that in as well. All right, good luck.